So therefore electric current density J equal to limit del x a s tends to del I upon del x cos theta equal to del I di upon dA cos theta equal to di equal to j dA cos theta equal to vector j dot vector dA. Current electricity integrating I equal to integration of di equal to integration a to j dot dA equal to j integration d equal to j equal to I upon a, where a is the entire cross sectional area. Now we are going to through the electromotive force and terminal voltage. The potential difference between the two poles of an electric cell is defined as the work done by the non-electric force due to chemical process taking place inside the cell in moving a unit positive electric charge from negative pole towards the positive pole. The energy gained by the unit positive charge due to the non-electrical force is moving it from the negative pole towards the positive pole is called the EMF, means electromotive force of the electric cell. Its unit is joule per coulomb equal to volt. When the poles of the electric cell are connected externally by a conducting wire, current starts flowing in the circuit. The direction of the conventional current is from the positive pole to the negative pole of the cell in the conducting wire. Actually, electrons move from the negative pole to the positive pole of the cell and the conducting wire. Inside the cell, current is due to the movement of the positive ions towards the positive pole and negative ions towards the negative pole of the cell. During the motion inside the cell, the charges have to overcome a resistance R of the cell. Some of the energy gained by the positive charge due to the work done by the non-electric forces is dissipated at heat in overcoming the internal resistance of the cell. This reduces its overall energy in the comparison with open circuit condition. Hence, the PD between the potential difference between the poles of the cell is slightly lower than when current is flowing as compared to the open circuit condition. This reduced potential difference is called the terminal voltage of the cell. The the relation between the EMF electromotive force epsilon and the terminal voltage V is capital V is V equal to epsilon minus IR. Now we are going to talk about the Ohm's law. You have read in your 10th standard about the Ohm's law. V is proportional to I, where V is the potential difference, I equal to ampere, and there is the constant R. Okay, so when we remove the sign of the proportional, there is need to have a constant R, that is called the resistance, and that's why its unit is ohm. That's why the V equal to Ri. So R equal to V upon I, volt upon ampere. The ratio of the potential difference V between the two ends of the conductor kept in a fixed physical condition and the electric current I flowing through it is constant. This statement is called the Ohm's law. This ratio is called the resistance capital R of the conductor. Its unit is ohms and symbol is ohm. Okay, the ohm equal to V upon I, volt upon ampere. 1 by R is called the conductance of the material. Its unit is mho, उल्टा हो जाएगा ओम का और साइन भी उल्टा हो जाएगा, एंड सिंबल इज इनवर्स ऑफ ओम. Metals, some insulators and many electric components obey Ohm's law to perfection, but not all materials. The graph of the I versus V will be a straight line for a conductor obeying Ohm's law at a constant temperature, but the resistance of the conductor changes with the temperature. देखिए, जो मटेरियल या कंडक्टर ओम्स लॉ को फॉलो करता है उसके पोटेंशियल डिफरेंस और करंट के बीच में अगर हम कोई ग्राफ ड्रा करें तो हमेशा वो स्ट्रेट लाइन होगी, और वही स्ट्रेट लाइन जो होगी वो ओम्स लॉ को फॉलो करती है. ठीक है, और जब ओबिंग ओम्स लॉ जब करता है तो उसका टेम्परेचर कांस्टेंट होता है, बट रेजिस्टेंस ऑफ द कंडक्टर चेंजेस विद टेम्परेचर, पर उसका रेजिस्टेंस चेंज होता रहेगा. सो इधर लो टेम्परेचर कांस्टेंट डी आई अपन डी वी, high temperature constant di upon dv. There is the x-axis shows the volt potential difference, and I is the current. Now resistivity. Resistance R of a conductor varies directly as its length and inversely as its cross-sectional area, capital A, at a given temperature. Means what are the factors that affect the resistance? R is proportional to I and R is proportional to 1 upon A. ठीक है, देखिए लेंथ के डायरेक्टली प्रोपोर्शनल होता है और एरिया के इन्वर्सली प्रोपोर्शनल होता है, तो R इक्वल टू रो 1 अपॉन ए, वेयर द कांस्टेंट रो इज नोन एज द रेजिस्टिविटी ऑफ द मटेरियल. इट्स वैल्यू डिपेंड्स ऑन द टाइप, temperature and pressure existing on the given conductor. Its unit is ohm per meter. Resistivity of a material of a conductor at a given temperature and pressure is defined as its resistance per unit length per unit cross-sectional area. Conductivity is the inverse of the resistivity. Its unit is mho per meter and or Siemens per meter, and its symbol is the rho or the mho per meter. Now the resistors. Resistors are the device which used in the electronic circuits. There are the two types of the resistors. First, wire wound, and the second, the carbon resistors. Wire wound resistors are the made of the magnetine, constantine, and the nichrome wires wound on a proper base. Carbon resistors are the small, cheap, and the widely used in the electronic circuit. There is the color coding of the resistor. Black shows the digit 0, 10 to the power 0. Brown 1, 10 to the power 1. Red 2, 10 to the power 2. Orange 3, 10 to the power 3. Yellow 4, 10 to the power 4. Green 5, 10 to the power 5. Blue 6, 10 to the power 6. मतलब यहाँ बेस 10 है और जो डिजिट्स है वो डिजिट्स की पावर चढ़ती चली जाएगी. होता क्या, रेजिस्टर्स जो बनते हैं वो चाहे कार्बन रेजिस्टर्स हो या चीप हो, उन सब पे एक सिंबल होता है और सिंबल कलर की रिंग होती है. उस कलर की रिंग की ये मेजरमेंट है. वायलेट जो है 7, 10 टू पावर 7. ग्रे 8, 10 टू द पावर 8. एंड वाइट 9, 10 टू द पावर 9. गोल्ड, येलो और सिल्वर है वो सारा जो है टॉलरेंस है. गोल्ड है तो -1 5% टॉलरेंस है, पॉजिटिव और नेगेटिव, और सिल्वर है तो 10 to -2 मतलब +-10% टॉलरेंस. नो कलर है तो 20% उसका टॉलरेंस होगा. स्लोगन टू मेमोराइज द कलर कोड, बीबी रॉय गोज टू बॉम्बे वाया गेटवे. ये कलर कोड को याद रखने का तरीका है. और देखिए यहाँ पर एक रेजिस्टेंस दिया है जिसका येलो कलर, वायलेट कलर, ब्राउन कलर और गोल्डन कलर दिया हुआ है. ठीक है. The value of the carbon resistors can be known from the color bands to the above figure and table. The first band yellow has number 4 and the second band violet has number 7. This forms number 47. ये 47 बनाएगा. The third band brown means 10 to the power 1. 10 to the power 1, and as read from the third column of the table, 47 into 10 to the power 1 gives 470 ohms as the value of the resistor. The last band of the golden color gives tolerance of the ±5%. Thus the true value of the resistors will be 470 ±5% ohm. Origin of resistivity. In vacuum, electrons have the accelerated motion due to the electric field. Contrary to this, electrons move with the some average velocity due to the electric field and a conductor under the steady state of the flow of the current.